Once we've converted a decimal number into binary, we can still do any mathematics on them as if they're decimal numbers. One of the mathematical operations is simple addition, where we can add two numbers and get a result. Let's take some simple addition in normal decimal notation. Say we wanted to add the numbers 28 and 46. We'll work through this addition step by step. We take the first column, add the 8 and the 6, giving us 14, which means we store 4 in the ones column and carry over 1. Then we add up the tens column, including the carry, which gives us 7. So we have a decimal value of 74. This is something I'm sure you're very familiar with. In order to be able to add two binary numbers together, you need to learn the rules of binary addition. These are 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, 1 plus 1 equals 1 0 or 0 carry 1, and 1 plus 1 plus 1 equals 1 1 or 1 carry 1. Let's try using this to add two numbers in binary. We're going to add 101 and 101. Now, 101 in decimal is the number 5, so 5 plus 5 should equals 10. 10 in binary is 1010. Let's see if knowing the answer means we can work it out correctly. Just like the decimal addition, we'll work through this step by step. Let's start by looking at the ones column. 1 plus 1 gives us 0 and carry over 1. Now let's look at the twos column. 0 plus 0 plus 1 equals 1, so there is nothing to carry. Let's now look at the fours column. 1 plus 1 equals 0 and carry the 1. Finally, we look at the eights column. 0 plus 0 plus 1 equals 1 with nothing to carry. This gives us a final number of 1010, which if you convert to decimal is 10, the correct answer. So let's try another example. Let's say we wanted to add 111 and 111. 111 is 7, so 7 plus 7 should equals 14, which is 1110 in binary. Let's start with the ones column. 1 plus 1 equals 0, carry the 1. Now let's look at the twos column. 1 plus 1 plus 1 equals 1, carry the 1. Now let's look at the fours column. 1 plus 1 plus 1 equals 1 and carry the 1. Finally, we look at the eights column. 0 plus 0 plus 1 equals 1 with nothing to carry. This gives us a final number of 1110, which if we convert to decimal is 14, the correct answer. There is another way of checking your work. That is to convert your binary numbers to decimal, add them, and then convert your answers back again. Say you wanted to add two numbers, 1011 and 1001. The first thing you do is to find the decimal values of these two binary numbers. The decimal value of this number is 11, 8 plus 2 plus 1. The decimal value of this number is 9, 8 plus 1. In the decimal world, 11 plus 9 is 20. So now, all we have to do is convert the decimal number 20 back into binary. So there you have it, 1011 plus 1001 equals 10100. One issue with binary addition is that sometimes the result of the answer can be too big for our available number of bits, and this is called an overflow error. Let's assume we want to add two 4-bit binary numbers, 1001 and 1001, which is 9 and 9 in decimal. Following the rules we learned in the previous section, answering this question should go as follows. Let's start by looking at the ones column. 1 plus 1 equals 0 and carry the 1. Now we look at the twos column. 0 plus 0 plus 1 equals 1, so there's nothing to carry. Let's now look at the fours column. 0 plus 0 equals 0 with nothing to carry. Finally, we look at the 8's column, which gives us 0 and 1 to carry over. But now we have a situation called an overflow. The resulting binary number needs more bits to store it than the original two numbers. Do you see how the product of the addition needs an extra bit to store the information? This is called an overflow error. The number of bits required to store your answer is bigger than the number of bits allocated. So, once we have converted a decimal number into binary, we can still do any mathematics on them as if they were decimal numbers. In order to be able to add two binary numbers together, you need to learn the rules of binary addition. If the number of bits required to store the answer is bigger than the number of bits allocated, then this is an overflow error.